And hello, welcome to this video. In this video, I want to start talking more about how we can get more in depth into Python coding with Salome. So first thing first, well, this is on a second computer that I have had. So let me install Git, and of course I want to get the Salome working. Well, like we have some bugs over here. We cannot install Git. So let me just do some debugging, let you know what's happened, and I'll get back to you. Okay, so I've installed Git. What actually happened? So to fix the bug that I had earlier, you go to etc etc apt sources.list. I added these few lines of code in the front. Where did I copy and paste the code from? I copied and pasted the code from this thing called making mirror mirror // mirror.ubuntu.com, highly available. Okay, so there's these lines of code which deb a mirror file. In this case, it's for Lucid, but that's an old version of Ubuntu. For our case, in Salome, we like to use Ubuntu 20.04. So we'll use focal, which is the name for Ubuntu 20.04. So we change wherever we see Lucid, we change it to focal. And then I actually ran an apt update and apt upgrade. All this is run as root. So this actually takes a while to do, but once you do that, things will be okay. This will actually fetch mirrors from all over the world, so it will take very much longer than your usual apt update and apt upgrade. Yeah, but this is a sort of an automatic thing that well, if you don't want to search for your mirrors manually, then you can go and get it done. Okay, so hopefully this will help. And as you can see, I've demonstrated now. It's actually lagging a little bit, unfortunately. But yeah, that's what you have to live with if you use this method of doing it. Otherwise, you just have to go and settle your own mirrors. Okay. And apparently, this thing seems to be installing OpenFOAM at the moment. You see OpenFOAM 2106. Okay, so that's what happened with the apt update and apt upgrade. Well, so pardon me, it's taking a bit longer. Necessary, longer than I thought, but yeah, it will give you a chance to sort of use OpenFOAM. Alright, so now yeah, that's good actually. Okay, so I'll be letting this thing update for a little while more, then I'll get okay, already updated, great. So let's get to Salome proper. I'll try to keep this terminal open. And of course, first thing first, I want to git clone. Let's do some git cloning. Clone this directory in, and yeah, should be done pretty quickly. And repository isn't that big. And after that, again, same steps. Or rather, I just want to copy one file here, which is the link git work directory file. Remember, so go to intermediate plus go to Salome and the link git work directory. I'll copy and paste it here. And then I'll run Salome, run it in the background by using n. Salome should start running. Now, yeah, now that we got this thing set up, how then do we want to proceed? Okay, so let's do some explanation while this whole thing is running. Salome is now running. Yeah, now that we run Salome, what do we want to do? Okay, so of course in Salome you can actually use the GUI, the GUI, to make cylinders and stuff. Pretty straightforward compared to coding anyhow. Yeah, you can use it to do this, but if you want to repeat it, like I said before, you want to use Python, right? So you want to use Python. on paintbrush. All right, so what can we do with Python? Okay, you start integrating your code with Python. Start integrating your code with Python. Okay, I use the shift button to actually draw straight lines, by the way. That's a nice trick if you are using GIMP. Yeah, if you want to use a Python, what can you do with Python? What are the strengths here? You can actually give inputs, like you can tell Python, I want to set a certain diameter and a certain height. Okay, so I can do that, or I can make very, very complex shapes. Okay, so the shape I have in mind is, of course, well, if you see my channel long enough, you know that I like to do heat exchanger work. Okay, so this will be a heat exchanger. There's an inner surface. Let me draw a straighter line. Be an inner surface and an outer surface, right? If I want to have many, many small tubes at the side, okay. So let's say maybe I want 7 tubes outside. Okay. So maybe the hot fluid will flow this way. The hot fluid will flow this way. And over here, on the outer tubes will be the coolant. Okay, outer tubes will be coolant, and they'll flow in a counterflow way. So I want all these tubes to be like so-called evenly spaced. Now, if I want to somehow vary the thickness of this heat exchanger, I want to vary the thickness of this pipe, I want to do it manually, there'll be a lot of steps. But if I put everything into a Python code, I can just change 1 or 2 numbers, and the script will potentially do all these meshing and everything for me automatically. That is the power of Python. Now, not only that, you can also use Python to export OpenFOAM input files. The standard way, a lot of people would know it will be using PyFOAM. Okay, no promises that I will be doing videos on that. I have not learned PyFOAM at this moment. I'm not using PyFOAM for my projects at this moment. But if you use a Python to automate your meshing, you can also integrate that with PyFOAM code, and then you can automate the meshing step as well as running OpenFOAM. And potentially, if you can put PyFOAM into your Python console, you can also run OpenFOAM from this Salome console as well. I don't know whether you want to do that, but that's the power of integrating things in Python. Okay, of course, for now I use Bash scripting for my OpenFOAM running, and that's how I tentatively want to stick to it. But yeah, again, just want to remind you of the potential. So yeah, without further ado, how do we start? So let's go to our Salome console. I'll be turning on the geometry part. And what do I want to do? I actually want to start dealing with hey, let me try resizing this. Yeah, I want to start dealing with our Python scripts. So let's link our Git work directory. Okay, so I've added this to the path. So what it means now is that I can go to thin pipe flow snappy hex mesh, intermediate plus, can actually add files in here and get things done. I'm going to make a directory called video scripts because I actually in my Git work directory, I actually added this path called video scripts under my Salome. These will be the scripts I will be sort of making in front of you, doing live demo in video. Okay, so now what actually do we want to do? Okay, so first, if you want to start get started with Python, let's just do a very simple case setup first. Okay, we'll make ourselves a cylinder, and then we'll mesh. Okay, we'll mesh that cylinder. So we go to mesh. Do this very quickly. This is a very simple setup. I'll make a mesh, create the mesh. I'll apply the NetGen 1D, 2D, 3D hypothesis. Apply and close. Then I will start to compute. And okay, it will be a very, very crude mesh, but it's a tetrahedral mesh. Can't expect too much from Salome. Okay, so I'm not gonna pan it around too much. But after you're done with the mesh, I actually want to export it. Okay, so we go to where's the export? Export, I want to go to export to this UNV file. So I'm going to just do this thin pipe flow snappyx mesh. I'm going to put into this folder, video scripts. I'll just call this thing mesh 1. Save it. And what do I want to do now? I want to actually dump all of this to a Python file. So I'll just call this tests. Okay, mesh and export Python dump. Okay, mesh and export Python dump. So if I actually run this code, this should be able to reproduce the exact same results here. So I'm just going to try and delete all of this. Go to the geometry module. Try to delete. Yes. I'll delete the mesh as well. Undelete. Okay. Not that bit. Okay. Go to geometry, I'll delete the origin and everything. Okay. That should be fine. Okay. So what exactly do I want to import? Remember, I want to do this import mesh and Python dump. I'm going to copy that, Ctrl+Shift+C, and import whatever it is here, mesh and Python dump. Okay, so see, the cylinder one is back. Okay, and along with all of this OX, OY, OZ things, vectors. Let me bring this out. Delete. Actually, I can just quickly do delete. Okay, so if I want to see what this looks like, it's the same cylinder. If I go to the mesh module, should be able to see the mesh one. Exactly the same. Okay, so that's what we have. Now let's just quickly examine the. We see this mesh one UNV is exported here, no problem. Let's see what the file looks like. Okay, mesh and export python dump.py. Okay, so you have all of this over here, all of these things over here. Then this will be how do you say, your initial files, and then you're inserting a very specific folder called this video scripts. It gives you the full I guess the full description. It doesn't give you a relative file path directory. It gives you the absolute file path directory for this. And then you see this little R thing here. This R here stands for raw, which means, well, for strings normally what Python will do is to remove all this this forward slash and backslash, and yeah, the strings might remove them. I can't remember where I read that, but this R thing is to say I want these forward slash and backslash in. Okay, so this is one. Okay, so yeah, you're inserting this path in here, just like we say, okay, if we want to import a certain path, let's import it there. Okay, so these things I think we might have visited before. This is actually making vertices and vectors to see the OX, OY, and OZ. Okay, this is your origin, and cylinder is being made by using this, calling this make cylinder RH function, radius and height. So radius is 100, height is 300. Not sure. Okay. Yeah, you can examine it on in your own time. Show you how. Okay, but usually once you make all these objects, you need to do something called add to study. So you have to add this to study, and the next part here is meshing, where you have to import certain meshing modules. Then you initiate a mesh object, and then you start making this mesh object based on a previous geometry or cylinder that you made. Then well, it calculates some things based on the mesh algorithm, computes it, and this part over here, which I'm highlighting, actually exports the whole thing to UNV. So you have the basic you have the very basic few steps here that that are needed to, let's say, start your, what do you call that? Yeah, to start your script or your class building. Okay, I prefer to do it in classes because it's very easy. It's much easier to integrate large segments of code using classes rather than just one or two functions or one or two scripts. Now, the good thing about things here is that, again, if you, let's say, want to make your radius and height a different value, you can just change the numbers here and thing will pop up in Salome in a very different manner. Of course, if you change in one place this radius and height, you have to change it in both places as well, especially if you're doing a series of 7 or 8 cylinders and you want to change all those heights at once. So again, the power of scripting is that you can change it all of this simultaneously. Okay, so now that we have this, let's start by making a class. Okay, because remember, at the end of the day, what we want to do is to make a very complex heat exchanger shape made up of a lot of cylinders. Okay, so we have this inner cylinder, we have this outermost cylinder, and we have all maybe 7 cooling tubes in between as well, all flowing in different directions. So we have a hot and cold fluid, sort of a heat exchanger, shell and tube, I don't know, what have you, kind of design. I'm just doing a very simple design based on tubes for the sake of demonstrating Salome Python scripting. And yeah, let's do something just like that. Okay, so again, the way to do this, if you want to make 7 or 8 tubes, is not just to keep doing these Python dumps. You have to so-called reverse engineer these Python dumps and convert them into a class. Okay, let's start making the class. So now that we are starting to discuss classes, I want to explain some philosophy of why I do things certain ways, why I'm very particular about having functions and comments being done certain. Okay, so in a tip, imagine if you're going to have a lot of code that builds this very complicated heat exchanger thing. Well, we're not just going to have 65 lines of code that we see here. We're going to have thousands of lines of code because we're going to have to think about not just exporting. We need to think about how to calculate, these distances between these cylinders. We have to make sure they don't overlap. All of these will have to be factored in. It's easily about 1 to 2,000 lines of code. Now, if you want to edit this 1 or 2,000 lines of code, then chances are you need to make your code. If you want to make this work, your code should be very, very neat so that you are able to find the segments of code you want when you debug. Okay, and debugging is a very painful process. You want to make this, you want to minimize the pain as much as possible. So that's why you want to make sure your code is very, just comes, I guess, with some experience. Okay, so I like to do things in classes, as I said before. So let's make something. So let's call this cylinder class. And if you want to skip this video, you can actually just look to this work example, and well, you'll see this thing called cylinder class here, and this is what I've actually written so far. It's not quite complete yet, but yeah, it does a very basic job of classes. So you can go and take a look at the code. The one I'm doing here may be slightly different from that, but the principles are more the same. Okay, so let's make the cylinder class. Well, maybe a live demo. I'll call it live demo. I'll call it a live demo cylinder class, okay? Because I'm doing it live in front of you. Live demo cylinder class. Okay, let's save this. And what I want to do now is declare class. Okay, class, we'll call it mesh builder, because we want to build a mesh. And I think I forgot to change it to py. Need to change this to a Python file so that all my syntax will come in. I start with class mesh builder. And the way to start the class is to start with a constructor. What is a constructor? A constructor is just one of the many functions in a class, which is automatically initiated every time you start. So this is the init class with the underscores, and I'll start with the self. Self is a instance of a class. I won't go through into all this. I assume you kind of know programming as Python. So that is some prerequisite you need to do. Yo. So this is my constructor class. Okay. Sorry, my constructor. This is the constructor. What do you call that? Function. Or as Python people like to call it, method. Prefer to call it function because that's how so this is a function. Okay. So so what can we do? We can actually save and quit first, and I want to have a live demo cylinder class and Python mesh and export python dump.py open simultaneously. So I'm going to vim both of them. Mesh and export python dump. So the way to switch between both of them, if you vim two files at once, use the bn and just use bn colon and bn. This will help you to switch between these two files. Okay, so yeah, first thing first, yeah, this is how I use it anyway. I think the other one's bw. I cannot remember the moment. I just remember bn because if I do two files, that's all you need. Okay. Anyway, so there are some modules you need to import first. So these are the modules you will need to import: sys, salome, salome notebook, import geom, blah blah blah. All of this will need to be imported into your class. Okay, so you want to automate all of this. So I'm going to bn, and let's make a function called dev import modules. Okay, import modules, and let's bn. I'm going to copy and paste all of this, and I'm going to do a Ctrl+Shift+V here. Okay, all of this will need to be indented. I think 8 spaces. So let's indent 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. And if you want to repeat these commands, just use the full stop or dot button. That's what I'm doing now. Okay, I'm going to then delete some unnecessary bits of code. Okay, for example, this notebook I don't really need. This syspath insert I don't really need. Salome init, I want to execute it in a different class or different function, or what do you call it? Okay, reason why I'm categorizing all of these imports into the same function is because, yeah, again, neatness is it's very high on the priority list. So we have all this imported in, and we want to keep it neat. So let's also categorize all this together. We want to get these imports over in the same function as well, or same class. So let's do that. So let's call this put this here, and for the neatness sake again, for neatness sake again, I'm going to copy and paste this mesh component here. Okay, so I'm going to again insert 8 spaces. So don't need to count 8 spaces anymore. You just take a look at the alignment. If they're all correct, they're all correct. Now, so are we done here? Okay, are we done here once this import modules function is run? Not necessarily, because once the function is run, all of these modules will therefore be deleted and you cannot use it in the rest of your class. The way to work around this, okay, what I like to do, may not be the best way, but it's the way I'm familiar with, is to load modules into the object or object instance. That means I'm going to load sys into this self object, salome into this self object, salome notebook into this self object, so on and so forth, so that it will be usable anywhere in the class. So self.sys equals sys, self.salome equals salome, and just as you're doing this, just expect to have typos and all, right? Self.salome notebook equals salome notebook. Self.geom equals geom. So good thing you only have to do this once, and you can just use this function again. Whatever modules. If you have new modules to import, you can just stuff them in here as you would do normally as well. From salome.geom, oh sorry. Okay, self.geom builder equals to geom builder. So this is the geom builder thing I'm doing. Self.math equals to math. Self.salome ds equals to salome ds. Self.smesh equals to smesh. Okay, I think we already did salome mats before, so we don't need to do this salome mats again. Salome mats is already here. We don't want to import it twice. It's really unnecessary. And self.smesh builder equals to smesh builder. What this will do is that it will load all of these modules into object instance and now be usable within the whole class. So that's how I start things. So first thing I'll just run self.import modules. Remember, always you have to put your self prefix in front, so that because if you just run import modules, Python will not know what you're talking about. But if you say, I want this import modules within this specific object, then you have to put this self dot thing here. Python will know. So the first part is to import the modules. First, we import modules. Okay. So now the modules are imported. We can just pretty much ignore most of this. Okay. Can ignore most of this. The next thing is to, I guess, initialize some defaults. For example, you have this salome init and the notebook thing over here. So that's important. We can categorize them under a different set of functions. So let's just add some. Before we do that, let's add some comments here. Okay. Import important. Oh, what a wordplay. Import important modules. And the next one is to set up salome case files. I don't know what's the word to use. I'm not exactly sure. Let's go. So we'll have the salome init and the salome notebook. Maybe we call it the initialize salome environment. Okay, or initialize salome notebook mesh def initialize salome. Maybe I'll just call it salome objects. The descriptive name, I hope. Paste this here. Okay, salome. So you basically look for this salome file, and then we run this salome in what do you call that? function. Okay, so well, we cannot just have salome here. We need to the Python will be very clueless as to where this salome is coming from. You need to tell Python, okay, I've already loaded salome into my self instance of the object. I want to get it from self salome init. Okay, so and again, so yeah, that's all you need to do to modify. Okay, that's why I like this version. Anyway, yeah, and you have notebook, the notebook bit. So let's do that. So here you see here you can initiate the salome notebook. Okay, so self.notebook equals to self.salome.notebook. Then you have this notebook function. Okay, so self.notebook equals to self.salome notebook. So this will make it able to set, you'll be able to access it within the class. So these are the things to initiate. And not just this, you actually have to initiate one more thing. This one, smesh. So because we also are initiating some meshing as well, so we'll need to have this smesh builder new, whatever this thing is. Okay, let's see. How are we doing this? Yeah, you need to copy and paste. Vn. Paste it here. Of course, you can use the visual copy and paste. It works just as well since both are within the same Vim instance. Self.smesh equals self.smesh builder.new. And then, well, if we are satisfied with this, then we can just run the function. Then we initialize salome objects. Self.initialize salome objects. We just do no inputs. Okay. So right now we have not done very much except to initiate some objects, but let's try to run this code and see what happens. Okay, so let me do this. Let's delete all of these things in the mesh. Delete algorithms, delete the mesh objects. Okay, I can't quite delete that for some reason. Oh, I need to go to geometry and I. Okay, let's delete all of this. Yeah. Okay, so this is what it is. Again, how do we import this class? So the way to do it is to, well, what is this class called? liveDemoCylinderClass. Okay, and what is the function called? The function is called mesh builder. So from liveDemoCylinderClass import mesh builder. That will be the syntax. liveDemoCylinderClass import mesh builder. Okay, and what do we do? That's it. Once you're done with that, we'll need to have a cylinder object equals to mesh builder. Then we just give it parentheses, and you'll start. So cylinder object. So this is the class, which actually doesn't print anything, which isn't all that great, but it shows that the syntax seems to run correctly. If I, let's say, yeah, I guess I'll stop here. I don't want to get too long-winded. This is a very long video already, 35 minutes almost. So I'll stop here and we'll talk about how to deal with some of these things. Okay, see you.